Welcome to our deep dive today.
Yeah.
Where we're going to be exploring something that you specifically requested. The fascinating world of psychedelics.
Okay.
But we're not just skimming the surface here.
Right.
You want like the professor-level explanation
Sure.
of how substances like ketamine and DMT work
Yep.
beyond their effects on serotonin receptors.
Yeah.
Especially when it comes to like cognitive function, altered states of consciousness, and their therapeutic potential.
That's right.
Yeah.
So we're going beyond the usual suspects like in the serotonin system.
Okay.
And looking at the intricate dance of other receptors like NMDA and Sigma-1 and the downstream pathways they influence.
So we got a stack of research articles and expert lectures ready to go.
Great. So let's jump in.
For a long time,
Yeah.
the prevailing understanding has been that psychedelics primarily exert their effects through serotonin receptors,
Okay.
especially the 5-HT2A receptor.
Yes, and while that's certainly a critical part of the story, groundbreaking research is revealing that it's not the whole picture.
Oh.
Other receptor systems play a significant role in the overall psychedelic experience, contributing to the unique effects of different compounds.
It's like we're discovering these hidden pathways in the brain, right?
Exactly. And these pathways are not just interesting from like a scientific perspective. They also have implications for understanding the therapeutic potential of psychedelics.
Okay, so let's start with ketamine.
Okay.
It's well known for its ability to block the NMDA receptor,
Right.
which is involved in learning memory and pain perception.
And that NMDA antagonism is thought to be central to ketamine's rapid antidepressant effects.
Okay.
However, what's really fascinating is that even when you block the serotonin 2A receptor, ketamine still produces profound changes in brain connectivity.
Wait, so you're telling me that even without the serotonin, ketamine can still significantly alter the way different parts of the brain communicate with each other?
That's right.
That's kind of mind-blowing.
It is. It challenges the traditional view that psychedelics work solely through the serotonin system.
Okay.
And suggests that other mechanisms are contributing to ketamine's effects, specifically on cognition and consciousness.
So if it's not just about serotonin, what else is going on?
Right.
What are these other mechanisms?
Research suggests that ketamine might be interacting with other receptors, including the Sigma-1 receptor and even dopamine receptors.
Hold on a second. Can we unpack the Sigma-1 receptor a bit?
Yeah.
What is it and why is it important?
The Sigma-1 receptor is a bit of an enigma.
Okay.
It's involved in a wide range of cellular processes, including stress response, neuroprotection, and the modulation of other neurotransmitter systems.
Yeah.
But its precise role is still being investigated. What we do know is that it's a key player in how certain psychedelics, like DMT, work.
Okay, so we've got ketamine possibly interacting with Sigma-1 and dopamine receptors.
Yep.
And we know DMT is involved with Sigma-1 as well.
Yes.
What does this mean for their effects?
That's where it gets really interesting.
Okay.
Ketamine's interaction with Sigma-1, for example, might contribute to its ability to reduce inflammation and promote neuroplasticity, which could explain some of its therapeutic benefits in conditions like depression and anxiety.
Neuroplasticity, that's the brain's ability to change and adapt, right?
Exactly. And the fact that ketamine might enhance neuroplasticity through these non-serotonergic pathways is a significant finding and suggests that we might be able to target these pathways to develop new treatments for a wide range of conditions, not just those traditionally associated with psychedelics.
So we're essentially discovering new ways to like potentially rewire the brain.
That's a good way to put it.
That's incredible.
It is. And it's important to remember that the effects of these substances are not solely determined by which receptors they bind to.
Okay.
The environment, the individual's mindset, and their past experiences all play a role.
Right.
We call this set and setting.
Right. I've heard that term before.
Yeah.
So it's like saying that even if two people take the same dose of ketamine, their experiences could be completely different based on their individual context.
Precisely.
Wow.
The set, meaning their mindset, intentions, and expectations. And the setting, meaning the physical and social environment, can significantly influence how the drug affects them.
Okay.
This is a crucial consideration, especially when we talk about therapeutic applications of psychedelics.
That makes a lot of sense.
Okay.
So we've laid some groundwork here. We talked about how the focus on serotonin receptors is only part of the story when it comes to psychedelics.
Right.
And we've introduced the idea that other receptors like NMDA and Sigma-1 are also involved.
And we've touched upon how these interactions might contribute to the unique effects of different compounds and their therapeutic potential.
Now, I know you mentioned downstream pathways earlier, and that's where I really want to dive deeper.
Sure.
Can you walk us through the specific chain reactions that happen at the cellular level when these receptors are activated or blocked?
Absolutely. In the next segment, we'll unpack these intricate pathways, starting with the NMDA receptor and ketamine.
Right.
Get ready for a journey into the cellular mechanisms underlying these profound psychedelic experiences.
I'm ready. This is where it gets really fascinating for me.
Okay. All right. Let's dive into those downstream pathways you're curious about.
Okay.
These are like cellular chain reactions set off by modulating receptors like NMDA and Sigma-1.
So we're talking about like the domino effect happening at the microscopic level within our brain cells.
Precisely. Understanding these cascades is crucial for grasping how psychedelics work at their core.
Okay, I'm all ears.
Okay.
Where do we start?
Let's begin with ketamine.
Okay.
And the NMDA receptor.
All right.
We know ketamine blocks NMDA.
Yeah.
But the really intriguing part is what happens next.
Okay.
This blockage actually triggers a series of events that lead to an increase in glutamate release.
Hold on, glutamate?
Yeah.
Isn't that an excitatory neurotransmitter?
It is.
I thought blocking NMDA receptors would reduce neuronal activity.
Right.
Not ramp it up.
That's a sharp observation. It does seem counterintuitive.
Yeah.
But here's the key.
Okay.
Many NMDA receptors actually sit on inhibitory neurons.
Uh-huh.
So when ketamine blocks them, it's like taking the brakes off those inhibitory neurons, allowing the excitatory signals to flow more freely, leading to that net increase in glutamate you mentioned.
Okay, that makes sense.
Yeah.
So it's not just about directly inhibiting activity.
Right.
It's about shifting the balance between excitation and inhibition in the brain.
Exactly. And this shift, this increase in glutamate, is thought to be crucial for the synaptic plasticity and neurotrophic effects associated with ketamine.
Let me make sure I'm following you.
Sure.
Synaptic plasticity is the brain's ability to change and adapt over time, right?
Got it.
And neurotrophic factors are like fertilizer for brain cells.
That's a great analogy.
Helping them grow and thrive.
And ketamine, through this intricate dance with NMDA receptors and glutamate, appears to boost both.
Wow.
This is thought to be a major factor in its rapid antidepressant effects.
So by blocking NMDA receptors, ketamine sets off a cascade. That ultimately leads to a more flexible and nourished brain.
Precisely.
That's fascinating.
It really is.
Yeah.
And it highlights the interconnectedness of these systems.
Right.
Modulating one receptor can have ripple effects throughout the entire network.
So, okay, we've talked about glutamate. What about calcium signaling?
Sure.
I know calcium is involved in all sorts of cellular processes.
Yeah.
How does that fit into the picture?
Excellent question.
Yeah.
Both NMDA and Sigma-1 receptor modulation can impact calcium signaling, though in distinct ways.
Okay, I'm intrigued. Break it down for me.
Okay, let's start with NMDA receptors.
Okay.
They're actually calcium channels themselves. So when ketamine blocks them, it directly reduces the flow of calcium ions into certain neurons.
That's straightforward enough.
Right.
But how does Sigma-1 come into play?
Yeah.
It doesn't directly control calcium channels, right?
Right. The Sigma-1 receptor is a more behind-the-scenes operator.
Okay.
It modulates intracellular calcium stores, influencing the reservoir of calcium that the cell has ready to use.
So it's like controlling the reserves?
Yeah.
Well, NMDA receptors are more like the gates controlling the immediate flow.
A perfect analogy.
Yeah.
And DMT, through its interaction with Sigma-1, is thought to affect the release of calcium from these internal stores, which can trigger a whole different set of downstream effects.
Okay, so we've got glutamate release being modulated by NMDA receptor blockade.
Right.
And calcium signaling being affected by both NMDA and Sigma-1.
Yes.
Are there other major players in these cellular chain reactions?
Absolutely. There's a whole symphony of signaling molecules that get activated downstream of NMDA and Sigma-1 modulation.
Okay, give me some highlights.
Okay.
What are some of the key players in this symphony?
One prominent example is BDNF.
Okay.
or brain-derived neurotrophic factor.
Now, BDNF. That's a name I recognize.
Right.
Isn't it crucial for the growth and survival of neurons?
Yes.
Like the ultimate brain food.
Exactly. And both ketamine and DMT,
Wow.
through their respective receptor interactions, appear to increase BDNF levels in the brain.
So the psychedelics could be promoting the growth and well-being of our brain cells.
That's right.
Even beyond their immediate effects on consciousness.
Precisely.
Yeah.
This BDNF boost is likely a major contributor to the neuroplasticity and potential therapeutic benefits of these compounds. It's like they're giving our brains a revitalizing spa treatment.
Wow, that's pretty amazing.
Yeah.
Are there other signaling molecules involved?
Oh, definitely. There's mTOR,
Okay.
a key regulator of protein synthesis. It's essentially the manufacturing process for building new proteins within cells.
Okay.
And then you have various transcription factors, which control which genes are turned on or off, influencing the cell's overall behavior.
It's mind-boggling how complex these pathways are.
It is.
But it's also beautiful how all these different pieces work together in such a coordinated way.
It is a testament to the intricate design of the brain.
Yeah.
And the more we learn about these pathways, the more we understand the power and potential of psychedelics to influence them.
It definitely feels like we're just scratching the surface of what these compounds can do.
We are. And these non-serotonergic targets, like NMDA and Sigma-1, are proving to be critical pieces of the puzzle.
Yeah.
They're helping us understand how psychedelics can induce such profound changes in consciousness and potentially offer new avenues for treating a wide range of conditions.
So what does all this mean for the future of mental health treatment?
Yeah, that's a great question.
How can we translate this knowledge into real-world therapies?
That's the million-dollar question, and it's what we'll explore in our final segment.
Okay.
We'll discuss how understanding these non-serotonergic targets could lead to more targeted and effective treatments.
Okay.
And the challenges and opportunities that lie ahead in this exciting new frontier of mental health care.
I can't wait to dive into that.
Great.
This is all so promising and really makes me think about the future of mental health in a whole new light.
Yeah, me too.
Okay, so we've gone deep into the cellular mechanisms.
Right.
And explored how psychedelics interact with these non-serotonergic targets. Now let's zoom out and consider what this means for the future of mental health treatment.
Yeah.
It feels like we're on the verge of something truly groundbreaking.
What's particularly exciting is the potential for lasting change.
Okay.
Traditional antidepressants often provide temporary relief.
Right.
But psychedelics, through their profound effects on neuroplasticity, might offer a way to actually rewire the brain and achieve long-term remission.
It's like giving the brain a chance to break free from those ingrained patterns of negativity and dysfunction, allowing for real transformation.
That's a great way to put it. And this is where the research on neuroplasticity becomes so crucial.
Right.
We've discussed how both ketamine and DMT can increase BDNF levels and enhance synaptic plasticity.
Right. BDNF being that essential growth factor for neurons.
Exactly.
Helping them thrive and connect in new ways.
And this increased plasticity could be the key to breaking free from those entrenched patterns that contribute to conditions like depression, anxiety, and even addiction.
Wow.
It's like giving the brain a fresh start, a chance to create new, healthier pathways.
So it's not just about masking the symptoms.
Right.
It's about addressing the underlying mechanisms in the brain that are contributing to the problem.
Precisely. And this concept of neuroplasticity is also central to understanding why psychedelics might be so effective in treating trauma-related disorders like PTSD.
Because trauma can leave those deep scars on the brain, right?
Right.
Making it difficult to process and move past those experiences.
Yeah.
It can feel like you're trapped in the past.
Exactly. And psychedelics, by promoting neuroplasticity, might create a window of opportunity for individuals to revisit those traumatic memories in a safe and therapeutic setting. And reprocess them in a way that reduces their emotional impact.
It's like loosening the grip of those traumatic memories, allowing them to be integrated into a new narrative, a new understanding of self.
That's a very insightful way to describe it, and this is where the integration process becomes so important. It's not just about the psychedelic experience itself.
Right.
It's about what happens afterward.
Right. It's about taking those insights and breakthroughs gained during the session.
Yes.
And weaving them into everyday life, making them meaningful and lasting.
Absolutely. And this is where therapy, both before and after the psychedelic experience, plays a crucial role.
Okay.
It helps individuals process, understand, and integrate those insights into their lives, creating a new sense of wholeness.
So it's a holistic approach combining the power of these compounds with the guidance and support of trained therapists to facilitate real healing.
Exactly. This integrative approach is key to maximizing the therapeutic potential of psychedelics.
Now, while all of this is incredibly exciting, we have to acknowledge that there are challenges involved in bringing these new therapies into mainstream mental health care.
Right.
It's not as simple as just prescribing a pill.
Absolutely.
Right.
There are practical considerations like training therapists to work with psychedelics, developing standardized protocols, and ensuring access to these treatments for those who need them most.
And we can't forget about the stigma surrounding psychedelics.
Right.
There's still a lot of misinformation out there, and it'll take time to educate the public and shift those deeply ingrained perceptions.
Yeah.
It's a cultural shift as much as a scientific one.
Very true. We need to emphasize the scientific rigor behind this research and dispel the myths and misconceptions that have long been associated with these compounds.
It's about presenting the facts clearly, highlighting the therapeutic potential, and emphasizing the importance of responsible use within appropriate settings.
Precisely. And we also need to navigate the ethical considerations. We're dealing with powerful substances that can have a profound impact on consciousness. So it's crucial to proceed with caution.
And ensure the safety and well-being of individuals seeking these treatments.
Right, because like any powerful tool, there's potential for both benefit and harm.
Exactly. We need to establish clear guidelines, screen individuals carefully, and provide appropriate support and integration to minimize any potential risks.
It's about finding that balance between pushing the boundaries of mental health care and ensuring responsible and ethical practices.
Indeed, and this is where collaboration between researchers, clinicians, policymakers, and the public becomes so important. We need to work together to create a framework that fosters responsible exploration while protecting individuals and ensuring equitable access to these potentially transformative therapies.
It feels like we're at a turning point. Standing on the threshold of a new era in mental health care. There's so much potential here. But it requires a thoughtful and collaborative approach to truly harness it.
I couldn't agree more.
It's an incredibly exciting time, full of possibilities.
And a time that calls for both optimism and careful consideration.
Absolutely. We need to embrace the potential of these new therapies while acknowledging the complexities, proceeding with both enthusiasm and wisdom.
Well, I think we've covered a lot of ground today. We've explored the science, the potential benefits, the challenges, and the ethical considerations surrounding these non-serotonergic targets of psychedelics.
And I hope we've provided you with a deeper understanding of these fascinating compounds and their implications for the future of mental health treatment. It's a rapidly evolving field, and we're just beginning to uncover its true potential.
This has been an incredible deep dive.
Thanks for having me.
I know I've learned a lot, and I hope you have too. Thank you for joining us today.
Of course.
And until next time, keep exploring.
Indeed, keep those minds open and those questions coming.